Everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about Stokes' theorem. Introduction to Stokes' theorem. Stokes' theorem is a fundamental result in a vector calculus that establishes a relationship between a surface integral and a line integral of a vector field over a boundary curve. It is named after the Irish mathematician Sir George Gabriel Stokes, who first published it in the mid-19th century. Stokes' theorem is a higher dimensional generalization of the Green's theorem, which relates a line integral around a simple closed curve to a double integral over the region. Overview of the vector calculus. Vector calculus is a branch of mathematics that deals with vector fields, which are the functions that assign a vector to each point in space. It extends the concepts of calculus from one-dimensional functions to functions of multiple variables and vector fields. First one is scalar and vectors. Scalars, it is quantities that have only magnitude, such as temperature, mass or distance. Next one, vectors, quantities that have both magnitude and direction, such as velocity, force or displacement. Vector operations, vector addition, combining vectors according to the parallelogram law. Scalar multiplication, scaling a vector by a scalar. Dot product, multiplying two vectors to get a scalar quantity. Cross product, multiplying two vectors to get a vector perpendicular of both. Vector fields, functions that assign a vector to each point in a space or a region. Differentiation of vector fields. Gradient, the vector derivative of a scalar function representing the rate of change and direction of the steepest ascent. Divergence, a scalar measure the spreading or converging behavior of a vector field at a point. Curl, a vector measure or the rotation or circulation of a vector field around a point. Understanding the line integrals. Line integrals are a fundamental concept in vector calculus that extend the idea of integration from one-dimensional functions to vector fields along the curve in a space. First definition, a line integral is an integral of a function of several variables along a curve in a space. It measures the cumulative effect of the function along the curve. Scalar integrals. For a scalar function f of x, y, z, the line integral along a curve C is denoted by integral f of x, y, z ds. Explanation of surface integrals. Concept of closed surface. A closed surface is geometric object that completely encloses a region in three-dimensional space without any holes or boundaries. Definition of a closed surface. A closed surface is a surface that forms a continuous unbroken boundary around a solid region in three-dimensional space. It has no openings or boundary curves and fully encloses the volume with it. Characteristics. Encloses a region. A enclosed surface surrounds and encloses a volume or region in three-dimensional space. Example, sphere, cube, closed cylinder. Representation. The surface of a sphere centered at the origin with radius r can be represented by the equation x square plus y square plus z square equal to r square. Stokes' theorem. Stokes' theorem is a fundamental result in a vector calculus that establishes a relationship between a surface integral of the vector field over a surface and a line integral. Statement of the Stokes' theorem. The Stokes' theorem states that For a smooth surface S bounded by a simple piecewise smooth positively oriented curve C and the vector field F defined on an open region containing S and C, we have integral F into dr equal to surface integral del cross F into ds. Visual representation of Stokes theorem. Visualizing Stokes theorem can be a bit complex since it involves relating a line integral around a closed curve to a surface integral over the region bounded by the curve. First one, line integral. Visualize traversing the closed curve C and computing the line integral of F along this curve. Surface integral, that is right side of the Stokes theorem. Imagine a surface S that bounded by the closed curve C. This surface could be any smooth surface with C as its boundary. The curl of F is denoted by del cross F. Stokes theorem connection. Stokes theorem asserts that the circulation F around the closed curve C is equal to the flux of the curl of F through the surface S bounded by C. Application of Stokes theorem in physics. Stokes theorem finds widespread applications in physics, particularly in the field of fluid dynamics, electromagnetism, and quantum mechanics. Thank you.